In this video, we'll go through exam questions that cover the criteria, calculate actual dimensions from scale drawings, and create a scale diagram given actual measurements. You can locate the questions on the mathsmaths.com website under Level 2. The questions come from different exam boards. We'll start with the non-calculator questions and then we'll move to the calculator questions. Here is the first one. Zach wants to include a map in his article. The map must be to scale. The map shows a part of the country that is 30 kilometers wide and 48 kilometers long. It must fit into a space that is no more than 12 centimeters wide and 16 centimeters long. The map is scaled down to fit into the space. In the article, what distance in kilometers will 1 centimeter on the map represent? So the space we have on the map is 12 centimeters by 16 centimeters. And in reality, the part of the country measures 30 kilometers by 48 kilometers. So we're going to need to fit 30 kilometers into 12 centimeters and 48 kilometers into 16 centimeters. So let's try. 30, if you divide that by 12, will give us the scale. So how many 12s fit into 30? 12 and 12 gives us 24. 30 take away 24 gives us 6. So we have 6 remaining there. We can put a decimal point here and a decimal point in the answer. And now we can add a 0. So how many 12s into 60? So let's try now. 24 and 24, that's 48. So we've got 4 lots of 12 in there, and we can keep going. 48, if I add 12 to that, that is going to be 60. So 5 lots of 12 make 60. So if we show 30 kilometers here, that would mean that 1 centimeter on the map is equal to 2.5 kilometers in reality. That needs to be the same for the length as well, because if it's not, then we haven't got this in proportion. So let's give this a go. We're going from 16 centimeters to 48 kilometers. So if we do 48 divided by 16, how many lots of 16 fit into 48? 16 and 16 gives us 32. 32, if we add 16 to that, get 8, 48. 3 lots of 16 give us 48. So if we fit the whole thing into 16 centimeters, the whole 48 kilometers into 16 centimeters, we have 1 centimeter is equal to 3 kilometers along the length. So we've got 2 different scales now, and we need to have only one, because length and width need to go in proportion. Which one do we pick? We pick the one that represents more, so this one here. Why? Because let's just give it this a go. So if we pick the first one, which is 1 centimeter equals 2.5 kilometers, that means that each of these centimeters here will be equal to 2.5 kilometers in reality. So the actual length will be 12 times 2.5, which would give us exactly 30 kilometers. We've done that already when we divided. So if we do the same now for the length, we're going to have 16 times 2.5. Let's see, what does that give us? 5 times 6 gives us 30, so 0 down, 3 carried over. 5 times 1 is 5, and the 3 is 8. We put a 0 down, and now 2 times 6 is 12, so 2 down, 1 carried over. 2 times 1 is 2 and the 1 is 3. Adding these together, 0, that's 10. So that gives us what? Where do we put the decimal point? So we've got no decimal places in 16 because it's a whole number. We've got one decimal place in 2.5. So we're going to give our answer one decimal place. So going backwards, we get 40 kilometers. So 16 centimeters would represent only 40 kilometers if we used this scale. And that wouldn't be enough because we need to represent along the length 48 kilometers, not 40. Whereas if we go with 1 centimeter equals 3 kilometers, then we can represent both the width and the length. There might be a bit more space in here on the map, but that doesn't matter. So you see, 3 times 16 gives us 48. If we do 3 times 12, gives us 36, which is more space than what we need, because we only need to represent 30 kilometers, but that's absolutely fine. So we're going to stick to 1 centimeter equals 3 kilometers. A statue is 20 meters high and 54 meters wide from A to B. There is A and there is B. Noah is making a scale model of this statue. Noah's model statue is 5 centimeters high. How wide is Noah's model statue? So the model is 5 centimeters high and the statue is 20 meters high. So 5 centimeters represent 20 meters. So 1 centimeter will represent 4 meters, because 1 times 5 gives us 5, 4 times 5 gives us 20. Now we're looking at the width. So the statue is 54 meters wide. So this is a statue, this is the scale model. What do we multiply 4 by to get 54? So we'll do 54 divided by 4. How many 4s into 5? That's just 1, and we have 1 remaining. How many 4s into 14? That's 3, and we have 2 remaining. We're finished with the digits, so put a decimal point here and in the answer, and we can add a 0 as well. How many 4s into 20? That's exactly 5. So that's 13.5. So we'll do the same here. 1 times 13.5 gives us 13.5 centimeters. So that's how wide the model will be, 13.5 centimeters. The distance between 2 villages on a map measures 6 centimeters. The map has a scale 1 to 25,000. What is the actual distance between the 2 villages in kilometers? So the scale is 1 to 25,000. When we don't have units like centimeters or meters or kilometers, that means whatever unit you use for one, you use for the other number as well. So we've got 6 centimeters. This will be in centimeters as well. So how do we get from 1 to 6? By multiplying by 6. And we'll do the same here. So 25,000 times 6. 6 times 0 is 0. So that's 3 times repeated. 6 times 5 is 30. 0 down, 3 carried over. 6 times 2 is 12, and the 3 is 15. So 150,000 centimeters. We've got to give our answer in kilometers. So we're going to convert this into meters first. There are 100 centimeters in a meter. So if I divide this by 100, which means knocking off 2 zeros, I'll get the answer in meters. So 1500, 1,500 meters. There are 1,000 meters in a kilometer, so I need to divide this by 1,000. So that will be 1, 2, 3 places to the left, so this is 1.5 kilometers. A model maker wants to make a model of a ship. He will use a scale of 1 to 50. The ship was 100 feet long. 1 foot is equal to 0.3 meters. How long will the model ship be in centimeters? So the scale is 1 to 50. 1 is for the model and 50 is for the actual ship. So the ship was 100 feet long. So how many feet will the model be? How do you get from 50 to 100? That's by multiplying by 2, or doubling. So 1 times 2 now gives us 2, so 2 feet. 1 foot is equal to 0.3 meters. What about 2 feet? That will be 0.6 meters. 0.6 meters, we know that in a meter there are 100 centimeters, because we've got to give our answer in centimeters. So 0.6 meters will be 60 centimeters. Simon is redesigning his garden. He has drawn his garden on the diagram below, where 1 square is equal to 1,500 millimeters. Using the grid, calculate the actual length of the garden in meters. Show your calculations and the workings out here. So we've got to give our answer in meters. We're given that 1 square is equal to 1,500 millimeters. Let's convert that into centimeters first. So we know that in 1 centimeter there are 10 millimeters. So if I divide 1,500 by 10, that will give me 150, knocking off a 0. So 1 square is equal to 150 centimeters. We know that in 1 meter there are 100 centimeters. So if I divide now 150 by 100, which gives me 1.5 meters, that means that 1 square is equal to 1.5 meters. So we know that 1 square is equal to 1.5 meters, and we're interested in the length only, not the width. So we've got 1 square, 2, 3, 4, 5, 6, 7 and a half. So we'll do 7.5 times 1.5. So 5 times 5 is 25. So 5 down and 2 carried over. 5 times 7 is 35, and the 2, that is 37. Putting a 0 down, 1 times 5 is 5, and 1 times 7 is 7. Adding these two together, 5 and 0 gives us 5, 7 and 5 gives us 12, so 2 down, 1 carried over. 3 and 7 is 10, and the 1 is 11. We're going to give the answer 1, 2 decimal places, so we've got 11.25 meters. Now we move into the calculated questions. Arya is involved in a community project group. The group are planning to build a pond in the garden of the local hospital. The pond has a path around it. On a scale plan, the width of the path is 6.7 centimeters. The scale used on the plan is 1 to 25. Calculate the actual width of the path. So we've got a scale of 1 to 25. So that's on the plan, and 25 is in reality. So the width of the path on the plan, that is 6.7 centimeters. We've got to work it out in reality. So how to get from 1 to 6.7? We multiply 1 by 6.7. So we do the same here. So 25 times 6.7 gives us 167.5. And that's the actual width of the path. Asif wants to grow potatoes. The Grow Potatoes website gives these instructions for planting potatoes. Potatoes should be planted in rows. There must be 75 centimeters between the rows and 50 centimeters between each plant in a row. There should be a gap of at least 50 centimeters between the plants and the edge of the plot. The space for planting potatoes is a rectangle measuring 4 meters by 2.5 meters. Use the scale plan on the next page to show how the potato plants should be arranged to fit the most potato plants. Draw a cross to mark the position for each plant. So we've got the space here, 4 meters by 2.5 meters. So we know that there should be a gap of at least 50 centimeters between the plants and the edge of the plot. So although we're not given the scale here, we can work it out ourselves. So if this is 2.5 meters, 2.5, that means that this is 1 meter. And this is half a meter, and this is quarter a meter. So we can use that. So in half a meter between the plants and the edge of the plot, so that would be 2 squares. So 1 meter, 4 squares, and then half a meter will be 2 squares. So 2 squares each way. So we could plant a potato here, and then we've got 50 centimeters between each plant in a row. So we can continue like this, keeping a space of 2 squares in between the plants. And then it says 75 centimeters between the rows. So that would be 3 squares. So the next one will be there. And we can continue within the row. Then 3 more squares, 1, 2, 3, which means we've got a gap here of 2 squares with the edge, which works absolutely fine. And that works. On a scale drawing, a water pipe is 27 centimeters long. The drawing has scale 1 to 50. Calculate the actual length of the water pipe. Give your answer in meters. So the scale is 1 to 50. 1 is for the drawing and 50 is the actual length or in reality. Now it says on a scale drawing a water pipe is 27 centimeters long. So we're going to put this under the drawing. So we're going to work out what length that is in centimeters in reality. So how do we get from 1 to 27? By multiplying 1 by 27. So we'll do the same here. So 50 times 27 gives us 1,350 centimeters. But we've got to give our answer in meters. We know that there are 100 centimeters in 1 meter. So if we divide 1,350 by 100, that will give us 13.5 meters. Fred has the scale plan of a kitchen worktop. The worktop has one line of symmetry. Fred will put tape along each edge of the worktop. He can cut and join the tape. A roll of tape is 5,000 millimeters long and costs £4.38. Work out the total cost of the tape Fred needs. So if the shape has a line of symmetry, then that must be here. It shows that both sides will have the same dimensions. So this one here is 26 millimeters and this is 26 millimeters. This is 60 millimeters, so this is 60 millimeters as well. And this is 24 millimeters. So he will put tape along each edge of the worktop. So we go around and we can add 26 and 24 and 30 and 24 and 26, 60, 90 and 60. So we'll add these now. Which gives us 340 millimeters. That is here on the plan. So total length on the plan is 340 millimeters. Got a scale of 1 to 25. So 1 is on the plan and 25 is in reality. And on the plan, that is 340 millimeters. How do we get from 1 to 340? By multiplying by 340. So we'll do the same here. So 25 times 340, which is 8,500 millimeters. and a roll of tape is 5,000 millimeters long and costs £4.38. So that means that one roll is not going to be enough. So he will need 2 rolls. So 2 rolls at £4.38 each gives us £8.76. An estate agent needs to know the area of a plot of building land. This plan shows the building land. What is its area? So we've got the dimensions on the map, and that is 60 millimeters by 66 millimeters. We've got a scale of 1 to 1250. So 16 millimeters, what that equal to in reality. So how do we get from 1 to 16? By multiplying by 16. So we'll do the same here. 1250 times 16 gives us 20,000 millimeters, that is, which we need to convert into meters because we'll give our answer in square meters. We'll convert this into centimeters first, and that will give us 2,000 centimeters. Dividing 20,000 by 10, because there are 10 millimeters in a centimeter, and now 2,000 divided by 100, because there are 100 centimeters in a meter, that will give us 20 meters. Now we've got 66 millimeters there, the length. How do we get from 1 to 66? By multiplying by 66. So we'll do the same here. 1250 times 66 gives us 82,500 millimeters again, which is 8250 centimeters, so 8,250 centimeters, and that is 82.5 meters. So now to work out the area, we're going to multiply 20 by 82.5, which is 1,650 square meters. The kitchen designer needs to draw a scale plan for a customer's new kitchen. The customer gives the kitchen designer this sketch to show how she would like the cupboards to fit above the worktop. The base of the large cupboard needs to be 50 centimeters above the top of the worktop. Use the scale plan of the elevation of the kitchen wall to show where the kitchen designer should draw the cupboards. So we've got the grid here. One square is equal to 1 centimeter, and we've got a scale of 1 to 25. So we've got these measurements in millimeters and some of them in centimeters. It makes sense to convert now. So I'm going to convert them all into centimeters because we've got centimeters being used here on the grid as well. So there are 10 millimeters in a centimeter. That's why 750 divided by 10 will give us 75 centimeters. 500 divided by 10 gives us 50 centimeters. 300 divided by 10 gives us 30 centimeters. So again, 50 centimeters here, 50 centimeters, and 30 centimeters. So we've got 1 to 25. The scale. So 50 centimeters, in reality, that will be equal to 2 centimeters on the grid. This one as well, because it's 50 centimeters. In terms of the depth, which is 30 centimeters, we're not going to really need that because it's not going to be shown on the grid. What about 75 centimeters? 25 times 3 is 75, so we'll do the same here. 1 times 3 is equal to 3, so that will be 3 centimeters on the grid, and this will be 2 centimeters. And this gap, that will be 2 centimeters as well. So let's start with the gap. So this is 1, this is going to be 2 centimeters. As you can see, we have the long cupboard here, and that is 2 centimeters wide and 3 centimeters tall or high or long, however you want to call that. So that's 1, 2, 3, and that's 2 across. Then we have 3 short cupboards, which are 2 by 2, so 2 centimeters wide and 2 high. And then we have a long one as well here. Now I haven't used the ruler, but it makes sense to use the ruler and draw the lines correctly. So let's just double check. We've got all of the 5 cupboards, a gap of 2 centimeters on the grid. We've got long cupboards 2 centimeters by 3 centimeters, and the short cupboards 2 by 2. A customer has asked you to install a new heater in the living room. You have this floor plan. You need to work out the volume of the living room so that you can advise the customer which size of heater you need to install. There are 3 heaters to choose from: Elite, Deluxe and Supreme. The height of the living room is 2.2 meters. 35.3 cubic feet equal 1 cubic meter. Which heater would you recommend for the customer's living room? So we'll work out the volume of the living room in cubic meters first, and then we'll convert it to cubic feet. So where is the living room? That's this one here. So we've got the key, which tells us that 1 square is equal to 1 meter. So we'll work out the area as if this was a rectangle, and then we'll take away this triangle there. So we've got length, that is 1, 2, 3, 4, 5.5, so 5.5 meters, and width, that is 1, 2, 3, 4 meters. So 5.5 times 4 gives us 22 square meters. Now, taking away the area of the triangle, that is 1 times 1 divided by 2. So height times base divided by 2. So that is 1 divided by 2, which is half. So 22 take away 0.5 gives us 21.5 square meters. So we've got the area for the living room. To work out the volume, we need to multiply the area by the height. So the height, that is 2.2 meters. So we're going to do 21.5 times 2.2, which is 47.3 cubic meters. Now, we know that 1 cubic meter is equal to 35.3 cubic feet. So what about 47.3 cubic meters? 1 times 47.3 gives us 47.3. So we'll multiply by 47.3 on the other side as well. So times 35.3 gives us 1,669.69. So where does that fit? That is in between 1,050 and 1,750 cubic feet. So we're going to pick Deluxe. You are helping to create a new play area at the nursery. The play area needs to be a rectangle that has an area of 54 square meters. You need to have the following equipment in the play area, and you know that the seesaw measures 2.4 meters by 0.5 meters. The climbing frame measures 2 meters by 3 meters. The sand pit measures 1.8 meters by 3 meters. Each piece of equipment needs at least 1 meter clearance from the edge of the playing space and other pieces of equipment. Draw the outline of the play area on the grid below. Draw and label the play equipment on the play area. There is a planning grid and a box for working out on the next page. Draw your final answer on the grid below. So we've got the grid, and 1 square is equal to 1 meter. The play area needs to be a rectangle that has an area of 54 square meters. So what could be the length and the width? If you think of the times tables, where do you come across 54? That is equal to 9 times 6. So 9 meters by 6 meters. So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Squares, and then we'll go 1, 2, 3, 4, 5, 6 down. So this will be the play area. Now let's draw the seesaw. which measures 2.4 meters by 0.5 meters, so that is going to be 2.4 squares by 0.5 squares. So I'm going to draw it here. 1, 2, 1, 2, 3, 4. So half a square, the width. So that will be the seesaw. And we've kept the distance of 1 meter from the edge of the playing space. Now we've got the climbing frame, which measures 2 meters by 3 meters, so that will be 2 squares by 3 squares. So we'll keep a distance and we'll do 2 by 3 squares. And then the sand pit, which measures 1.8 meters by 3 meters, so that is 1.8 squares by 3 squares, which shows me that I should have probably drawn the seesaw here. So that was half a meter by 2.4. And I'll create the space here for the sand pit. So 3 by 1.8. And we've kept a 1 meter clearance from the edge of the playing space, as well as in between the different equipments. And we've got the seesaw, climbing frame, sandpit. We've drawn an outline of the play area. We've drawn and labelled the play equipment on the play area. You make several craft items which you sell online. One of the items you make is the wooden photo frame. The photo frame is made of a backboard measuring 40 centimeters by 25 centimeters, a top and a bottom piece measuring 45 centimeters by 5 centimeters each, 2 side pieces measuring 20 centimeters by 5 centimeters each. Make a plan of the pieces of wood that will make up the frame. Use the graph paper on the next page to draw the 5 pieces of wood. Use a scale of 1 to 5. Show any workings in the box below. So we've got a scale of 1 to 5. So 40 centimeters. That will be equal to 8. Because 5 times 8 equals 40, so 1 times 8 gives us 8. 25 centimeters, that will be equal to 5 centimeters in the grid. Then we have 45, so 45 divided by 5 gives us 9. 5 divided by 5 gives us 1. 20 divided by 5 gives us 4. Again, 5 divided by 5 gives us 1. So we're drawing a backboard which measures 8 centimeters by 5 centimeters on the grid. And as we're not told anything about this, 1 square is equal to 1 centimeter. So 8 squares, 1, 2, 3, 4, 5, 6, 7, 8 by 5. 1, 2, 3, 4, 5. Then we have top and the bottom piece measuring 45 centimeters by 5 centimeters, so that is 9 by 1. One, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to call these top piece and bottom piece. And finally we have the two side pieces which measure 4 centimeters by 1 centimeter. So 4 squares by 1 square. One, two, three, 4. So side piece and side piece. So we've got backboard, top piece, bottom piece and two side pieces. Let's have a look. So we've done all of these. We've met the criteria. The property development company buys a house. They're going to build a conservatory on the outside of the longest wall of the lounge. This is the scale plan of the ground floor of the house and the garden. The floor area of the conservatory must not be greater than 1/3 of the floor area of the house. The length of the side attached to the lounge wall will be 4.8 meters. They will build the largest conservatory they can. How wide will the conservatory be? State the correct units in your answer. Show your working out and write the answer in the box below. So the first criteria that we've got here is the floor area of the conservatory must not be greater than 1/3 of the floor area of the house. So what is the floor area of the house? There we have the house. So we've got 1, 2, 3, 4, 5, 6.5 centimeters for the length, and the width is 1, 2, 3, 4, 4.8. The scale is 1 to 125, so what we're going to do is 6.5 times 125, which is 812.5 centimeters. So that will be, in terms of meters, 8.125 meters. And the width, that is 4.8 times 125, gives us 600 centimeters, which is 6 meters. So now multiplying 6 by 8.125 should give us the area. Which is 48.75 square meters. And now the floor area of the conservatory must not be greater than 1/3 of the floor area of the house. So if we divide 48.75 by 3, should give us 1/3 of that, which is 16.25. And if we know that the length will be 4.8 meters, what will the width be? So length 4.8 meters, width we don't know, but we know that 4.8 times this number will equal 16.25, which is the area. So to find that missing number, we're going to do 16.25 divided by 4.8, which is 3.385 meters. The table shows the items needed for the playground. We've got one climbing frame, space needed 6 meters by 6 meters square, one swing set, 10 meters by 4 meters rectangle, one sandpit semicircle with radius 6 meters, 2 rockers, each 2 meters by 2 meters square. The playground is drawn to a scale of 1 to 200 on a centimeter grid. On the grid, design a possible playground. So we've got a scale which is 1 to 200. So 1 will be on the grid and 200 will be in reality. We've got a centimeter grid, so we're going to use centimeters. We've got these given in meters though. So 6 meters, that is 600 centimeters. So that is 600 centimeters in reality. How many centimeters will that be in the grid? How do we get from 200 to 600? By multiplying by 3. So we'll do the same here. So 1 times 3 equals 3. So this will be 3 centimeters by 3 centimeters on the grid. And 10 meters by 4 meters. Okay, so that will be 5 centimeters by 2 centimeters. If you notice, when we had 6 meters, that was 3 centimeters. So now we halve in it. So that's going to be 5 centimeters. Half of 4 is 2. Semicircle with radius 6 meters, so that's going to be 3 centimeters. And then this one will be 1 centimeter by 1 centimeter in the grid. So let's start with a climbing frame. 3 centimeters by 3 centimeters, so it should be 3 squares by 3 squares, as this is a centimeter grid. Okay, maybe try and put it here. Climbing frame, now the swing set, that is 5 by 2 squares. So if I do it here, Let's see if we have space now for the rest. The sandpit, so semicircle, half a circle, with radius 3 squares. So 3 squares, that doesn't fit here, so I'm going to try and do it here. 1, 2, 3, 1, 2, 3, so I'm going to remove this. 3, so diameter is equal to 6 squares. So this looks like this. Okay, so I removed the swing set, which was 5 squares by 2 squares. So let's see if I can fit that as well as the 2 rockers, which are 1 by 1. It doesn't say that we need to keep space in between each item, so 1, 2, 3, 4, 5, this would work here, and 2 rockers, 1 and 2 of them, so this should be okay. Let's double check. It doesn't say anywhere that we need to keep space between the different items. We've got a climbing frame which measures 3 by 3 squares, a swing set which measures 5 by 2, a sandpit which measures, well, has a radius of 3 squares, and we've got 2 rockers, 1 by 1. So this was for practice. Now we're going to do this for real here. You'll need to use a compass or protractor to draw this properly, a semicircle. And of course use a ruler to draw the rest of the items. Now we should label these. So, rocker, rocker, climbing frame, swing set, and sandpit. Pete has a scale diagram of the living room in the apartment. Pete wants to cover one wall with wallpaper. The width of the wall on the scale drawing is 15.9 centimeters. The scale is 1 to 60. The wallpaper Pete wants comes in rolls of width 0.53 meters and length 10.05 meters. Costs £13.85 per roll. The height of the room is 2.65 meters. Pete cuts the rolls into lengths of 2.65 meters. Work out the total cost of the rolls of wallpaper that Pete needs for the wall. So we can imagine the wall looking like this. We've got the width of the wall on the scale drawing being 15.9 centimeters, whereas the scale is 1:60. So this is for the scale drawing and this is in reality. So on the scale drawing, the width of the wall is 15.9 centimeters. How do we get from 1 to 15.9? By multiplying by 15.9. So we'll do the same here. So 60 times 15.9 equals 954. So 954 centimeters, that is 9.54 meters. So I've converted that because we're working with meters later on as well. So we can write this here, 9.54 meters. And the height of the room is 2.65 meters. Now the wallpaper rolls come in widths of 0.53 meters, so you can imagine strips like this here, each strip being 0.53 meters wide. So how many strips will fit into 9.54? We're going to work it out. So 9.54 divided by 0.53 gives us 18. So 18 strips are needed. The length of each strip is 2.65. So if we do 18 times 2.65 should give us the overall length. Which is 47.7 meters. Each roll is 10.05 meters long, so we're going to do 47.7 divided by 10.05 to work out the number of rolls needed. Which is 4.75. So we've got to say 5 rolls. Because you can't buy part of a roll, and you can't buy less. So it better be a bit more. 5 rolls, and the cost is £13.85 per roll. So we'll do 5 times 13.85, which is 69.25. So that is £69.25. And that's the final answer. Molly has a scale drawing of the side elevation of the conservatory. The scale of the drawing is 3:50. The height of the conservatory on the scale drawing is 23.4 centimeters. Is the actual height of the conservatory less than 4 meters? You must show your working. So the scale is 3:50 and 3 is the scale drawing and 50 is in reality. We've got the height of the conservatory on the scale drawing being 23.4 centimeters. So under scale drawing we'll put 23.4 centimeters. So how do we get from 3 to 23.4? So we'll do 23.4 divided by 3, which is 7.8. So we'll do the same here. 7.8 times 50 gives us 390 centimeters, which is 3.9 meters. So 390 divided by 100, because there are 100 centimeters in a meter, which gives us 3.9 meters. So is the actual height of the conservatory less than 4 meters? Yes, it is, because it's 3.9. and that is less than 4 meters. So we're going to say yes. And that's the end of the questions.